In this video, we're gonna design a top level file for our project. This is our final top level entity design for this project. That means that we're gonna put together all of the design that we have designed previously for hex decoder, n-bit add structural, and n-bit behavioral. So we're gonna put all this file together into a single design. So we need to first of all to create a new Verilog file which we're gonna put all our which we're gonna instantiate our modules. So let's save it as final lab final, and then we need to declare the module for this design. So module lab final, so end module, and then the modules that we're gonna instantiate are the structural module, behavioral, and the hex decoder. So those are the files that we're gonna use in this file here, and then we need to declare our input and outputs here. So the common one are X and Y, and then we need to put our outputs for the hex encoder. So because this is hex encoder is going to be displayed on the digital hex, so all these are output, and then we have a carry out and overflow bit. And then we need sum because we must have a sum here too. So we're gonna put it here. For example, we have sum, but that sum is different for what is coming here because this is sum for we're gonna talk about it next. But the declaration of inputs, so input, so X and Y are 4 bits, so is X and Y. And then we have inputs. So inputs that we're gonna have here are on the structure and behavior. We have input control, which also must be declared here too. So we have input control, and then and then we have outputs, which are sum. So we have sum, which is 3 bits too. And then so we need to give name for our module, so we can call it module 1, module 2, and module 3. And then we have another output too, which are all of these hex, which are single bit. and we have so those are our outputs, and then we have a carry out and overflow. Carry out and overflow. So first of all, we need to design, our goal is to select sum, which this one depend on which design we want. For example, if you want to use structural, we're going to use structural. If you want to use behavioral, use behavioral. So we need to use a multiplexer in order to choose which result to use, either structural or behavioral. We need a multiplexer, which we're going to use our always function, so which is event driven. And here we need an if statement. So for example, if select, so we select the model that you want. For example, if select is true, begin, we select our module that we want, else and then if select is true, we select all the results from structural. If it's false, we select all results from behavioral. So here we need to create, for example, sum. So we can say sum it's equal to, so here we have sum, and then we have a carry out. So a carry out 2 is something that we want to display. And then we want to display also overflow. But okay, overflow, since overflow is 1, we don't need to use it, since the behavior doesn't have overflow, so overflow can be like this. But the other thing that we must notice here is that since we are using always block, which is event driven, we need to declare sum as a reg. And then carry out as a reg. So we need another output reg. And then we can take this out if we don't need it. So we can use non-blocking. I think that is okay. When this is true, we want to select sum, but we need to declare also a wire which will hold the value for sum for structural and sum for behavioral. So those are 3 bits too. So we can call it sum1 and sum2. So for example, we can say sum1, sum2. So those are internal wires. And then here we can say if it's true, we want to select structural, so we need to use sum1. So we write sum1. And then and here it's sum2. So that means that if select is true, we are displaying the result as sum, but if it's false, we are displaying the result as sum2 for behavioral. This is for structure. And for the carry out, we need also, since we have both carry out here, we need a wire for carry out, but carry out is single bit. So we need carry out 1 and carry out 2. So we can call it carry out 1 and carry out 2. So we can use this one here and this one here. So let me use non-blocking assignment. So now I think we have covered most of the thing here. What this event driven, it must listen for something has changed. So select. So if we switch the select button, it should run this code here, and then we need a sum. If sum changes to, we need here. I mean, if sum 1 changes and sum 2 changes, and if carry out 1 and carry out 2 changes too. So if there's a change on those input, we need to run the code. Carry out. That is good. And then we must make sure that sum is reg is true here. And then here, our input for decoder, we must use sum, not s, because this one is not declared. So we need to use sum here. Sum for index 3, which is the 4th bit, and then we need sum the 3rd bit, the 2nd bit, and the last bit. Like that. So let's save it and try to analyze and synthesize to see if we have some error issue. Let me close all the semicolons. Okay, let's save it and analyze and synthesize. Yes, we have some errors here. Let me look. 11, 15, 11 and 15, 15. Yeah, we see we have a semicolon here, and we have a semicolon missing here. Save it again. Try to another exercise. Okay, I see we have some errors here. We need to declare our select. So we're gonna put it here, select, which is this one, select. We need to have it, and then we have to have it as input. and we have error in carry out line 23. So here, okay, carry out, have carry out here. Okay, this is should be small c. Save it again and analyze and synthesize. Okay, so yeah, we don't have any errors now. So on the next video, we're gonna try to create a test bench file and test to see if we have done everything correctly, that our results are showing for as that we had on the previous design for both structure and design, and if the hexadecoder displays the result too.